This is the Matthew in the launch system. The multibeam in the Matthew is an EM710. It's a half a degree by 1 degree resolution system. Quite good. These are the specs on the Fugro Shoals 1000 system. This is kind of sort of a summary of our requirements, just above high water and actually out to 25-30 meters depth. You can spec spot density. Again, because of cost, we chose 5 by 5 meter, which is likely the worst. But we couldn't afford the 3 by 3 if we wanted to. But what we did is, in some areas, we did 3 by 3 meter density, and now we take a close look at that to see if compare different densities and try and determine what's the optimum density that we should fly for navigation purposes to detect. Make sure we're detecting all the shoal areas. From the LiDAR, you get X, Y, and Z bathy. You get the reflectance. They also fly a digital camera, vertical digital camera, and they take vertical photographs at a rate of 1 per second, 1 hertz. So you get high resolution, imagery also, that from which you can make a auto-rectified mosaic and so on. And so another use of LiDAR we did was, this is the south coast of Newfoundland, Burin Peninsula here, Lamoline, Green Island. This is the Canada-St. Pierre-Miquelon boundary here. So one of our base points obviously is on the boundary, but we have several base points among these rocks and islands here that are used to determine our offshore boundaries, such as 200-mile EEZ and now under Article 76, the limit of continental shelf. So again, in anticipation of going to the Arctic, we did sort of a test project with our Love2Sea people to see if LiDAR, how useful LiDAR is, and what resolution we should use to detect some offlying rocks. Because a lot of these charts are old and not necessarily on good horizontal datums. So GPS these days, we want to use the best available. Also, what I'll point out in this, you'll see the very near shore strip here is so. With the LiDAR system, the first return from the surface or the shore, in this case the land-water interface, is very close to the bottom return is very close to the surface return because of the shallow water. Typically, in the area from 0 to 1 meters, the two pulses are practically merged, and it's very difficult to differentiate them. So during the automated processing, this 0 to 1 meter band basically gets missed or rejected because of invalid returns according to the automated algorithm. So what they need to do is go back and they use a so-called shallow water filtering process, which is more interactive than anything, and they interactively or manually try and pick off a bottom return to fill in that gap. And we've done that. So this gap generally mostly gets filled in. It's a very critical area, the land-water interface, so we want it. I think that's the end of my presentation. So this is CISMO, Coastal Zone Mapping and Imaging LiDAR. That's under development in the U.S. So I guess these are some of the other books. Like I said, it's LiDAR, vertical photography, and I think probably a CASI hyperspectral scanning system also is involved. Okay.
How is this information or the data sets that you gather through this collection being shared with the provinces that are part of the Regional Adaptation Collaborative, who are themselves?
Always the first question.
Yeah, I know.
That hasn't changed in 20 years either. When can you have the data, right?
Well, I don't know.
That was my question.
The data, collected under, it's DFO, CHS data. A couple of the sites, as I mentioned, are in collaboration with industry, so there might be some, we have a non-disclosure agreement with them, but it's subject to our data sharing policies, which generally say it's certainly available for research in DFO, not to be used for commercial use or making charts. Maybe Michelle might have more updates on.
Basically, what happens is the data set will be taken, and again, like I talked about yesterday, probably made into a grid, about a 50-meter grid, and then that would be available. But you're looking at probably a year and a half before it goes through all the process and makes it to the database and it's available.
Okay. And how do you request it if you wanted it? Is it an official kind of thing, or you just call?
Yeah, there's a phone number I can.
There's an online form,
Yeah.
a data request
Okay.
form. Fill it
Okay.
out. What you want, where you want, and the more precise with coordinates and sketches, it's better for us to, because it's not going to ask you, give me all your LiDAR data or give me all the data.
Give me all your data.
Does it work
Okay.
the other way as well?
Does the stick up?
Does it work the other
And
way as well?
you got to outline what the purpose of the use of the data is, and then sign an agreement with us, and we promise not to sell it or
There's a form.
make navigation charge
Okay.
from it.
But I guess,
Chantal
yeah,
again.
just my, because I think some of the provinces are also doing LiDAR at certain, like Prince Edward Island, I think, is embarking on that. So I mean, it works both ways. If they're doing it in a similar fashion, can they
It's
share
all
that
on land.
with you,
They,
or-
they've that
It's all land.
PI with land, top of LiDAR.
Yeah, because they're trying to do coastal for the erosion.
It's all topo.
Okay,
so
so it's
they
not the
don't-
same,
I mean, we can use it somehow to determine the shoreline, but
not
So
too correct.
Jennifer and then
they don't have
Jeff.
the low water line usually.
Just on the reverse of that, what about some of the products that might be coming out of it, like the various shoreline definitions, the higher high water, the low water,
Yeah.
maybe some of the reflectance data results, what's in the plans? Are there opportunities for collaboration, or are they
Yes,
already coming out of that?
The Eastern Shore, one thing I didn't mention is, we were equipped with about 30 sites because we weren't sure of the weather, and it was bad in Newfoundland, we'd come back to Nova Scotia and so on. So we got several sites from the Oceans Center, IMI, next West Heads group, I guess. But we tried Scattery. We actually flew Scattery and Bird Islands, but the weather we got nothing in return. So Eastern Shore was one of their areas. So we'd probably pursue something. Yeah, hopefully.
Jeff?
Everything costs money though.
Sure, Jeff Cogman with DFO Oceans in Newfoundland. I believe at one of the previous meetings, it might have been Michelle, I think, mentioned that there was some LiDAR flown for Placentia Bay, was it?
Yeah.
Because I know John Shaw and those guys have done a lot of work in doing up some multi-beam work in seascape mapping in Placentia Bay, and I was just wondering about, I know it takes a bit of time to get through all the data collection and to work it up, but would there be any indication of when the Placentia Bay stuff might be?
We're just getting it from Frugo now. Yeah, like I said, I didn't have an overhead, but I'll list the sites that we did several. We flew from Argentia to Cape St. Mary's. That's the Cape Shore, as you know. And we did sites in Marystown and Grassy Point, Whiffin Head, that area. We also have Point of Coney near Sydney, Nova Scotia, done, Cape Ray, Eastern Shore. We also did Mahone Bay, the western part of Mahone Bay, let's say from Chester down to Mahone Harbour, with mixed results. We again, it was bad timing. We only got maybe 6 to 10 meter there, but it's a good data set. We have sites in Strait of Belle Isle, and just 2 weeks ago, we got funding from DFO Gulf in Moncton, and we flew Bucktouche, Tracadie, Miscou, Rishabukto, St. Mary's Bay in PEI, which is one more site, so DFO Mountain will be getting that data. I think, you know, there are very turbid water, rivers, you know, most boards I know. So I think the results were not as good. I think maybe 2 to 4 meter penetration, but it's very shallow there anyhow. So.
But they were looking mostly for Gerard.
Yeah. But that's a quick summary of sites that we have at the moment.
About availability for the private sector for consulting activities, we do a lot of work, reconstruction, and whatever.
It's the same process.
Same process.
Same.
Yeah.
How extensive is the ground truthing campaign that you have to do with these surveys?
Depending on what, for us, our focus is on the bathymetry, so we, not a lot. As long as we go there with our acoustic systems and do a small patch, overlap with the LiDAR and ensure the vertical comparison is good.
What kind of?
But you can go back further with, if you're doing habitat mapping, you probably will want to go back with cameras, sampling, which would be a much bigger campaign, obviously.
I think it's concerned with bathymetry right now. We're doing ground truthing because it's kind of new. So
Yeah.
once we get comfortable with it, I don't think we'll do anything.
Do you have an increasing error with depth?
No, it shouldn't be. Not that I know of.
What kind of role does substrate play?
I mean, the algorithms, you also, the water column properties, there's a refractive index model, there's obviously refraction. So that's, as long as those algorithms are robust and you get a decent pulse from the bottom, it's good.
Because you're going to get different problems at different depths. In
Yeah.
shallower, the two signals are almost together, so you have that problem.
Yeah.
In deeper, you'll have it.
Yeah. Signal attenuation, if it's, I think they blamed the lack of penetration in Mahone Bay on the algae bloom, but now that we went back with our sonar systems, they're finding even the high frequency sonars, we're having difficulty getting returns in 10, 20 meters, and it's because of the silt and mud bottom problem.
So substrate
Yeah,
is a
yeah.
significant factor.
So the layers might be just, you know, being absorbed, attenuated. because of
Presumably
type seabed.
in the quartz sand, you have a very good return accuracy.
And ideal areas are nice, low, constant slope with a, you know, sandy, good reflective bottom. But you don't always get them.
One of the other things with LiDAR, like Gerard mentioned, like your footprint is 5 meters by 5 meters, so you don't really get the resolution that you would get with the multi-beam at a half degree that you'll get a meter. So,
Shallow one. I think we're going to find that the 5 by 5 meter density is probably not good enough for charting critical areas. And all the quotes we got were just to go from 5 meter density to 3 meter was about double the cost. Because they basically fly it twice, and at slower speeds, lower altitudes, so you get just about double the time.
Okay, great. Thank you very much, Gerard.